In this lesson, we're going to look at implementing encapsulation in Java. Encapsulation is the essential idea that really separates objects and classes from structures. In a data structure that includes behavior, you know that the behavior is closely associated with the data, so it's clear what methods should be used on the objects. And we'll know when performing maintenance that we need to ensure that the methods and the data structures need to stay in sync with one another. Encapsulation allows us to prevent direct access to the data elements, instead forcing users of the object to interact only with methods. This might seem like a bad thing. After all, does this not simply prevent you from doing something? Well, the point is that while you do pay a small penalty inconvenience when you write the code, your job in maintaining it becomes much easier. And on balance, this is a huge benefit. Further, you'll discover that you don't need to understand as much about other people's code to be able to use it. And this makes it much easier to use the vast swathes of library code that Java includes. Another huge benefit to productivity. Let's start with a working project. This one is date2. We'll review what it does and then we'll discuss some changes that we might make to it. So the main method that we come into here creates a date object and it sets the date so that it represents the 29th of February 2012. Let's take a look at the date class itself that was defined for this. The date class includes a day, a month, and a year fields. It also has the supporting structure necessary to provide a constructor that allows us to initialize those directly. And that is how we are constructing it here. So we construct new date with those fields, and that will invoke this constructor to do the initialization. Then, this particular one, we still have a call to increment the day field of meeting date. And of course, it's probably not a big surprise that when we run this, that will actually create a date of February 30th, 2012, which is clearly not valid. We'd also know that if we create this better meeting date object here and invoke the next day method, the next day method defined within that object specifies how to compute the next day even if there is a leap year involved and if there is February involved, or depending on how many days in the month there are. So this will always compute a correct next day. So what would be nice is if we could find a mechanism that prevented us from accidentally messing up the internal representation of a data structure. In other words, we really don't want to be allowed to arbitrarily increment day. Well, it turns out that this is actually quite simple to do. If we go to the top of our date class and we replace this keyword public with the word private, and we're going to do that for each of these fields, what that says is that the only place you are allowed to access this variable by its name is inside the most immediately enclosing curly braces. So that means all the code that is here, manipulating the days in the month and checking for leap years and deciding how to handle next day, can refer to this.day and can increment it and behave accordingly. But outside of the curly brace that starts here and ends here, we can't access that any longer. So let's go back to our program, and you'll notice that it's immediately thrown up a whole bunch of errors. Well, the first error, if we hover over here, says date has private access in date2.date, which is this class over here. What that's saying is you're not allowed to do that any longer. That's a good thing because it prevents us from accidentally manipulating this day field in a way that is inconsistent with its intended use. So we can no longer do this. The downside, however, is that we also can't access the fields day, month, and year to read the values inside the date. So the question then becomes, how can we print out the date? Clearly we need to be able to use these values to make this object useful. Well, there are a couple of ways we can go about this. If we look at the date class itself, what we could do is provide methods that give us access to read these values. If you think about it, being able to read the value is not damaging in this case. It's the manipulation of it without understanding the consequences of that manipulation that is dangerous. So when we want to add to the date, we would be forced to call this next day method. But when we want to read it, we could just have a method that says get the day, get the month, and get the year. And in fact, this idea of creating getter and setter methods, as they're called, or accessor methods, is sufficiently commonplace that there's actually a mechanism built into NetBeans for creating this code automatically. So if I right-click on the source window and come down to Insert Code, I can say Insert Getter Methods. It then offers me the question as to which of the fields I want to have getter access to. Well, I'm just going to select all of them, please, and then tell it to generate the code. And you'll see it's created these methods. They're publicly accessible methods called getDay, getMonth, and getYear. And this is actually a naming convention that says you take the name of the field, you capitalize the first letter, and you add the word get. And then all we do is it simply returns that to the caller. So now, if we save that one and come back to our program that uses it, all we need to do to print out this month would be to replace this reference directly to the variable element with get month and put the parentheses on so that that becomes a method invocation. And we've got one too many there. There we go. And then we need get day, and we put the parentheses in, and get year with a capital Y, and we put the parentheses in. And you'll see that now this is no longer complaining. So that gives us one means of actually accessing that date. Clearly, of course, we are no longer incrementing that meeting day, so we would probably need to say meeting date dot next day. And that way we will actually increment that correctly. If we choose to comment out this piece of code for the time being, toggle comment, we can actually run this. So if we save it and then run it, we should see that this version has now generated the correct date and has successfully printed out the date. But there's something else we can do with a date. What we're really saying when we add these methods for next day and similar things is that it is the responsibility of this class date to understand how to manipulate the variables within it. So is it not also reasonable to think that this class should know how to represent itself as text? And actually that is also an idea that is built into the Java language. It turns out that there is a method that the compiler can use to convert any object into a piece of text. And what that method is called toString. So let's inject into this a definition of a toString method. The essence of it is that we say it is public. When you're now beginning to realize that means we can access it from anywhere. It returns a string. Its name is toString with a capital S. It takes no arguments because it's going to turn this object into a string. Then we compute the string that we want to represent our result by adding this.month with a slash separator, this.day, another slash separator, and this.year, and we return it to the caller. Because this method is special and the compiler knows about it, there's a little bit more going on here than we necessarily know about right away. And because of this, we're going to put this little magic word in here, @override, and notice it's a capital O after the @ symbol. This is to do with the fact this method is special, but this isn't the right place to go into details. So now what we can do, if we come back to, let's first save that, and then we come back to our program code, I'm going to uncomment this line and then add to that, concatenate with the better meeting will be on string plus better meeting date. And I'm just going to put the semicolon on the end. Now remember, before what we did was to call bettermeetingdate.month and extract the value of the variable. We can't do that any longer because it's private. We could say .getMonth and use the behavior to get it. But what this amounts to is an automatic invocation of the toString method. So let's actually leave that toString in there. We'll save this and run it. And you'll see that now it prints out better meeting will be on 3/1/2012. And in fact, if we delete the explicit invocation of the toString method and run the code again, nothing changes. In other words, when the compiler needs to take any object and turn it into a string so that it can concatenate it with another string, it will call that toString method. There's one more question that we should look at now. What does static mean when it's applied to a method? And why did we have that on many methods that we've looked at up to this point, but now we're creating most of our methods without it? The essence of this issue is that the methods we're creating now are used in the context of a particular object, and as such, they don't use the keyword static. Methods that are used without being applied to a particular object must be labeled static. Static is a really odd word to use to make this distinction, but that's been inherited from C++, the language that was a precursor to Java, so we're stuck with it. And there we have it. In this lesson, you've learned how to encapsulate the fields that describe the data in our data structures. Now we know that once those fields are inaccessible from outside of the data structure definition itself, or the class definition to use the proper term, we probably need to create other methods, like getter methods, to provide access to those values, and we'll create some methods which allow us to interact with the computational model, if you like, that this data structure or class now represents.